Mira Business FM, Dubai's home of business radio.
It's the morning drive. We know that the UAE is leading the charge in the global AI race. Now, from government services to logistics, artificial intelligence is important for our digital economy, but behind every smart algorithm and every ChatGPT query is a physical powerhouse, quite literally the data center. And data centers have a unique thirst that the industry is now working tirelessly to quench, if you'll excuse the pun. Now, how do we balance our massive digital growth with the precious water resources of our region? Is sustainable AI the next big investment frontier for the Gulf, is a question. Joining us in the studio, Dr. Ali Muzaffar, who is an assistant professor at the School of Mathematical and Computer Sciences at Heriot-Watt University here in Dubai. Now, Ali specializes in the intersection between AI, cybersecurity, and future tech. And he's here. Ali, it's very good to meet you.
Thank you. Thank you for having me.
Very good to have you with us. When we think of AI, Ali, we kind of think of the cloud or all the invisible code running down like the Matrix on a screen. But there's a very physical side to this that I think, we don't pay a great deal of attention to. First question, big question, why do massive data centers need so much water in the first place?
Yep. I think there's a very physical side to AI, and it involves, and it comes down mainly to heating and cooling.
Yeah.
So we need to think of it, let's make things a bit more simpler. When you actually log into ChatGPT, for example, and you send a query or you send a prompt to ChatGPT, what happens is that query goes to a server in a server farm or a data center, and then that data center will actually process that query for you. And that processing involves using of LLMs, maybe even training a bit more data, maybe learning from something which has been taught to it beforehand. And that processing produces quite a lot of heat. And to actually absorb that heat and to make the systems run continuously, we need cooling systems. Again, to give a simpler example, think about it as like work PCs or home PCs and laptops, where you have these laptops, and if you start running an intensive program on it, you start hearing the fans rev up.
Yeah.
That is the air cooling systems in our home laptops and PCs. Now, when you scale it up to thousands of processors that are used in AI, whether they be CPUs or GPUs, we need a lot more than air cooling systems, because air cooling systems are not that efficient. That is where water comes into play. Water is much more efficient in absorbing heat, and what these data centers and server farms do usually is they use liquid cooling systems that run water around hot components, absorbing heat from them, and then releasing that heat through heat exchangers. And as you said as well, we live in a water-stressed region, not a lot of fresh water reserves available to us, so we rely a lot on these desalination plants, for example, to get our cooling liquid from.
Okay, so the infrastructure behind the AI models, if I just type in to ChatGPT anything, that infrastructure needs constant cooling to keep the high performance stuff going. So AI workloads generate a lot of heat, so hence water-based cooling systems. I'm with you. As AI deployment accelerates, researchers are warning that water demand tied to these facilities is rising accordingly, understandably. Here's something to put this into context, and you can tell me if this is complete nonsense or if there's any truth in this. A single 1 megawatt data center consumes as much as 25 or so million liters of water annually. And this is the context, I think. That's enough to meet the daily water needs of 300,000 people. So each facility is kind of equivalent to a small city. Is that a fair assessment, or is that slightly sensational?
It may be a bit sensational, but I think the numbers would be quite close to that.
Right.
There is a lot of cooling required to run these GPUs and CPUs. Again, if you scale it down to our home PCs, etc., people who actually game quite a lot would have liquid cooling systems within their homes as well for their PCs. So just think about it, when you have thousands of processors running at the same time, billions of queries coming in at the same time through ChatGPT, through different data centers. The heat does get quite a lot, and yes, there is the issue of then how much water is being consumed and how can we actually optimize it.
Right. I suppose if you've ever, I don't know, gamed with a laptop on your lap, as the name would associate, you start to realize that it does generate heat, and it does it really quickly. Okay then, so it really kind of puts AI data centers at the heart of a growing environmental debate, doesn't it?
Yeah, it does. And it begs the question, how can we actually optimize it even more, even further? There are regulatory conditions coming in all the time as well to optimize it. There's a lot of research that is happening right now. There is AI being used to actually optimize AI. So it is in the forefront of research, how to optimize, how to make AI more sustainable, more ethical as well at the same time.
You used a phrase there, AI being used to optimize AI. So AI is being used to look at ways of making AI better.
Yeah.
That's a circle. I don't know how you square that circle if you're even supposed to, but that seems like some kind of a statement about the future of where we're going with artificial intelligence as much as anything.
It is, and it is actually a very positive discussion to have, actually. This is one of the more positive directions that you can go with this kind of a discussion.
Yeah.
So what happens usually is you have your data centers, and you would have an AI overlooking those data centers, basically monitoring water temperature changes, humidity changes, adjusting when does the data center actually needs more cooling, then when it does not need, saving a bit more energy, saving a bit more water resources that we have. So just having that AI on top, just monitoring all of these. So you would use AI, IoT systems to combine them together, have sensors, identifying when there is a need for more cooling. So let's say at a certain point of the day, the AI is able to then predict that this is a certain part of the day when there will be more queries coming in. Therefore, the processors are going to work much harder at that time, and therefore, you will need a bit more cooling to be introduced into the system. And that goes with actually other systems as well. In computer science, we have seen this for quite a long time now, that the system or the infrastructure is being monitored by the same concepts that the infrastructure has been made for. For example, in internet routing, we have algorithms that look for packet loss and so on, so that it can redirect routing on the go. On top of that, actually Google's data centers are quite famous for this. So what they do is they use reinforcement learning. Reinforcement learning is basically a computer learning from the decision it has made. So it would, again, monitor all of those metrics, so humidity, temperature, things like that, adjust cooling times, and with time, it would improve itself by looking back at how well did it do. So it would improve its strategy and so on. So again, there's a good loop over here that you use AI for the infrastructure that the AI is running on.
Well, it's a much more effective loop than humans because we tend to not learn the lessons of history, don't we? But computers are able to access, and computers at this level, systems at this level, are able to access incredibly quickly and incredibly accurately and learn from mistakes. I get it. AI workloads taking up more and more global computing activity. That we're seeing. We're all using it. You search for something, you get your AI overview. So AI is more and more embedded in everyday services. So attention is shifting from what the technology can do to what it consumes, I think, in some ways. UAE is a leader in desalination, water tech innovation, lots of research, lots of work being done. How can we leverage our expertise in water management to make data centers here more efficient, perhaps the most efficient?
Yes, so the UAE already has and operates major reverse osmosis desalination plants. We have one in Tawila, which actually produces 909,000 meter cubes of water per day with significantly lower energy and emissions. And the aim of the government is to have 90% of the water by these RO plants by 2030. This will provide a low carbon source of cooling water. not only for data centers, but also to actually produce these water as well. On top of that, there's a lot of work being done on reusable power, renewable power. We know UAE has worked and researched quite a lot on nuclear power plants as well. As per DIVA, Dubai's water utility plans to produce 100% of the desalinated water using renewable energy by 2030 as well. So again, there's a lot of emphasis on using clean energy. And once you have this pipeline going where the water that is being produced for cooling is being produced through renewable energy, through reusable technologies, that makes the whole process of then using those water or using that water for the cooling systems in data centers as well. And I think if done correctly, the UAE can set a global benchmark of using the advanced digital infrastructure it has, and that it can coexist with responsibly with the growing demands of AI as well.
I mean, there are lots of examples of this, and there are other things happening as well. The Khazna data center in the UAE is piloting a treated sewage effluent for cooling as well. And I was looking at Equinix, which is in Canada. They're using lake water and geothermal systems in Toronto to reduce consumption. So there are other ways. There are other emerging systems, closed loop systems that recycle water and air-cooled setups that rely on outside air rather than evaporation. The thing is, things like this. I mean, how quickly are we likely to see alternative cooling systems in order to conserve water? 2030 is only 4 years away. I'm amazing to say it's only 4 years away now. It seemed like the future last week.
Yeah. I think there's a lot of work being done over here in this field right now. There are regulatory conditions coming in all the time. So, for example, water consumption is already becoming one of the major metrics in Gulf water neutrality targets. And regulators are pushing for these closed loop systems as well, where you can actually go on to save 96% of the processed water. So you reuse water again and again.
Yeah.
And that is usually the case with these cooling systems as well. They do focus on using closed loop systems as well.
Yeah.
However, that still does not cater for the demand that we will have. So as per Modern Intelligence, data centers in GCC, this is including UAE and Saudi Arabia, are projected to consume over 426 billion liters of water annually by 2030. Now this, to put it into context, is a sharp rise from what we had last year in 2025. In 2025, 119 billion liters of water was consumed by AI. So with the rise of AI, with the growth of AI, this is only going to go up and up. Increasingly, customers and investors in the Gulf are also paying attention to how much water data centers use. And how do they publish these metrics, whether they are actually working on sustainable cooling systems or not. And they put them down in their conditions to invest, to give capital to these companies as well. So this is becoming one of the norms in the industry, obviously because it's still relatively new in terms of the issues that we're facing. We are still trying to figure out how we can actually optimize it a bit more. We are still trying to figure out what are the actual issues as well. So it will take a bit more time, but I think we are heading into the right direction right now with regulatory and how the customers are thinking as well now.
There's another aspect here, isn't there? Energy grids are going to face more strain as desalination plants, ramp up production to meet data center demands. Electricity generation capacity is going to need to grow if we're going to support AI infrastructure and the desalination that's needed to cool it. So there's a real need to innovate. There's a real need to adopt technologies that reduce water dependency. So I guess, I was trying to think this through last night, that's a real challenge. But if there's a challenge, there's an opportunity there.
It is. And as you said, actually, if you go back around 4 to 5 years ago, the demand for GPUs rose significantly, almost overnight. And that is, again, because of AI. What you could essentially do now is, in your home PC, you could actually set up an LLM, set up a small sample of a ChatGPT, for example. And without actually giving your data to external sources, you can actually get responses from it. And to do that, you need GPUs. And the demand for that rose, so the price rose as well. So I think the challenge over here would be, because with the emergence of AI and with the rise and the growth of AI, more power will be required. I think the challenge again definitely is how can we have more reusable technologies, more reusable energy to actually produce this power. And that is actually amplified over here in UAE because we live in a water stressed region. We need desalination plants, and desalination plants require a lot of power as well.
Yeah, so there's an urgency there, isn't there, I guess? I know that Masdar in Abu Dhabi are testing, it's like a solar-powered atmospheric water generator, and it takes moisture out of the desert air. I don't know how far that's gone, but that's one kind of innovation that could be happening. And the NEOM project in Saudi Arabia have got some quite advanced cooling technologies as well. So the cooling sector's going to be a boom sector in not too many years as well. From a business perspective, efficiency often equals profitability. Do you see water-efficient AI becoming a competitive advantage for tech companies operating in the Middle East?
I think absolutely. Goes back to the point that this is a water-stressed region. We need to have efficient water cooling systems, or else it's going to be really costly. And in a water-stressed region, in my opinion, efficiency is not just a sustainability concern. It's a financial and a strategic one as well. So companies that invest in water-efficient cooling, reusable technologies, and reporting these metrics in a professional and open manner would most probably be reducing their operational costs in the long term.
At Heriot-Watt University, you're the next generation of computer scientists. You're training the forthcoming generation of computer scientists. How is the curriculum changing to make sure that tomorrow's AI architects are thinking about not just about artificial intelligence, but also about, I guess, I don't know if this is even a phrase, but environmental intelligence?
It is. I think what I've seen is for the past 5 years, so I joined full-time 2 years back, but I was a PhD student at the same university 5 years ago, and I was teaching as an adjunct at that time. I saw the change gradually coming in during the COVID years. We are increasingly emphasizing that technical skills are not going to be enough for you as a developer, as an AI engineer moving forward. Students need to understand the broader impact of what systems they are building, what systems they are designing, what models they are actually training, and the broader impact it will have to real world as well. This means teaching AI alongside sustainability, ethical issues with AI, and system level thinking as well.
Yeah.
And the idea over here is that we have courses which are designed that teach how to use AI in sustainability and how to make AI sustainable as well. So we are going into both directions. We're seeing more and more students taking up projects which use AI. So again, for the past 5 to 6 years, we have seen more final year projects and master projects that are working towards machine learning models, training those models, and so on. And what we have done to actually teach a bit more and to have a bit more practical experience and to raise a bit more awareness about ethical and sustainable AI is that for each project submission that we have, whether it be an undergraduate project or a postgraduate project, the students need to actually submit an ethical form. This ethics form will basically ask the student as to how the data will be collected, how the data will be used, whether it is being collected in an ethical way, whether it's going to be sustainable to actually carry out these experiments or not. So they need to explain that before they can go to the next stage of actually doing their work as well.
So much more holistic.
Much more holistic as well. And we have seen dissertation projects, and we have a lot of processes actually working on optimizing AI. That is their research focus as well. And we are seeing dissertation projects working on efficient and sustainable AI, especially with power grid systems as well.
Yeah.
And the aim is basically to graduate AI professionals that can build powerful systems while also designing responsibly for the future as well.
There's a lot of talk about AI for good. Can AI be the solution itself? Can we use machine learning to actually optimize and reduce the footprint of the data centers that house it? I mean, I guess we're kind of seeing that, the beginnings of that now, aren't we?
Yeah, so again, a machine learning model, as long as you have good synthetic data, and actually right now, even if you don't have synthetic data, if you have raw data as well, we have moved into that, as we were talking just before the interview as well, we are in the technology area, right?
We are, yeah.
And the field is moving rapidly now. So once you have data, you can train machine learning models, and these machine learning models then are able to actually monitor the data centers for different metrics, for different parameters, and see when the demand for cooling is higher, when it is lower, and adjust accordingly. And we have seen this work in power grids as well, and we will be most probably seeing this work quite a lot more in cooling systems as well.
Last question for you. For anybody listening or watching now who might be in the business community, investors, tech leaders, whoever it might be, what's the one kind of standout moment that they could take away from this conversation regarding the future of AI or sustainable AI in this region?
I think the key message is that sustainable AI should not be seen as a brake on growth or innovation. It is quite the opposite, in fact. It is what will enable long-term resilient growth. So as AI scales, previously the hidden constraints used to be the power required, the computational power required, the talent required. But as we have seen in our university as well, more and more students are opting for AI specialism. So there will be a lot of talent coming through. So now the more important constraints are going to be the water, energy, and infrastructure resilience. And organizations that recognize this early and design their systems intelligently will be the ones that will actually move ahead of their competition as well.
Do you know what? It's been fascinating. You're a cybersecurity guy as well as an AI guy. So I've got some AI cybersecurity stuff crystallizing in my head at the moment, forming. So I'm going to have to invite you back. For now, Ali Muzaffar is assistant professor, Heriot-Watt University here in Dubai, talking AI and sustainability and cooling and more this morning. Thanks for coming in, Ali.
Thank you. Thank you for having me.
Do appreciate it. It's The Morning Drive. It's Mira Business FM. A like, a subscribe. We always appreciate. Get in touch. Tell us what you think on our social channels. And remember, everything we do is available to listen and or watch again, or both. Find us wherever you get your podcasts as well. Just search Mira Business FM.
Mira Business FM.